So which is better, a good pish or a good
Greetings, the Astro 30 here, back again with another exciting installment of this Class D amplifier build. We're up to part 5 now, and I'm doing the input selector. Now, the input selector itself may not seem like an important part, but it actually is, because, well, we need to be able to, select inputs. So, this is based on the designing a simple input selector, which I'll link in the description below to part 1. It's exactly the same, and the premise is the same: to keep it as small as possible, have 4 line inputs, 1 tape input and a tape out. There was one criteria I forgot to mention in that part, was it needed a separate ground for the signal as from the ground or negative reference point that drives the circuit, so the grounds had to be separate. And because this is going to be powered off of the 30 volt AC part of the power supply in that amplifier, it's not really going to have a ground reference on that point, so we needed a separate ground for the signal ground compared to the actual circuit ground. So with that criteria also implemented, you'll see I've got 2 circuit boards that aren't drilled or cut to size yet. That's the switchboard. I had to remake this because I routed the tape switching wrong. The VCC line was in the wrong spot. Yeah, so that was wrong too. This over here is for the protect LED on the front panel, so that's not actually really relevant to this particular circuit. Up here is the main circuit board where the RCA sockets are going to be mounted to, and the relays. I fixed the problems that the other one had. That was with using a Xeno diode. There was just, when you started drawing current more than 50 mA, the voltage started to clamp down even further. Which is what a Xeno does. It clamps the voltage down. It doesn't care. It's trying to keep the voltage below its maximum rating of the diode. So if the diode was rated at 15 volt, the diode will clamp down and below 15 volt. And the more current you draw, the more it's going to clamp down. Which is why using a Xeno diode works fine for powering preamps, because they don't draw any more than 40 mA max, but won't work when driving a relay. So I've changed that to a 12 volt regulator with 2 dropping resistors. We'll have a look at the schematic to fix that issue. So now I've got to drill these boards out and mount some components. You'll notice there's 2 pads here. These are for right-angled brackets to mount to the circuit board, which then have screws passing through the back panel into the brackets, just to give this, because this is the back of the board, just to give this a little bit more structural rigidity when mounted to the case, so that when you're plugging in RCA sockets, you're not just relying, RCA plugs, you're not just relying on the screws that hold the RCA sockets to the panel to provide rigidity for this board. Because over here we've got an extra RCA socket which doesn't actually have any panel mounting screw, so you push on that, it's going to push on the board, so hence why there is going to be brackets there to sort of eliminate that problem. We'll get to what this socket is for in a minute. So this is my component overlay diagram. Not much has changed except the addition of a 5th relay, and we'll look at the schematic as to what that is for, plus this extra RCA socket. So everything else is the same, except I've changed the power connector from a 2-pin locking connector to a 2-pin terminal header with screws. We've still got our main filter capacitor here, which is 22 microfarad. And now we've got another one over here, which is going to be a 10 microfarad. Again, we'll look at the schematic in a minute. and a voltage regulator. So the rest of the circuit's the same, so I won't go through that. However, let's look at the schematic now. So looking at the schematic as a whole, not much has changed. You've got all your inputs over here and a tape out as well, and all the relay switches and the drivers here, but over here is where it has changed. So over here we have our unfiltered I've put 25 volts, it's going to be 30. It's for all intents and purposes, it doesn't matter. We've got our unfiltered 30 volt AC coming in here. Going through this 1N4004, which is a half wave rectifier, and that's going through this small filter capacitor 22 microfarad. Now the reason why it's only a small one is to not so much deal with the ripple, but to stop the relays from chattering because there's no filtering there. Plus it'll help this regulator downstream a little bit so it's not handling all the ripple. Now that goes through these two resistors in parallel, which are 470 ohms, and the 1 watt devices, and that will give us roughly 245 ohm when all said and done at 2 watt. Now I did a calculation and found that I needed around about 20 volts at the input of this regulator, because this 7812, I believe their maximum input voltage is only 30 volts. It may be 35, I can't remember offhand without looking at the data sheet. However, we've got 30 volt AC coming in here, which is then rectified and then slightly smoothed. So if you really want to apply the DC RMS law to that, we're looking at roughly 42 volts DC here. So these dropping resistors don't actually drop the voltage to 20 volt. It's basically
ohms. It's not just fun, it's the law.
I've always wanted to use that piece of video that I created somewhere, but basically it's actually reducing the current to this regulator. And because current, voltage and resistance are all interrelated, if you lower the current flow through the circuit, you're actually reducing the voltage as well, because current and voltage are interrelated. So when all said and done, we should end up with about 15 volt here, theoretically. I did a calculation and it worked out it needed to be 80 ohm here to drop the 30, I think I said 42 volt DC down to 20. So that seemed a little bit small to me, and it required about a 3-4 watt resistor. So I jiggled the figures around a bit and came up with about 240 ohm. So hence these two resistors here. So they don't limit the voltage, they drop the current. Anyhow, that forms a VCC line after it's regulated at 12 volt. We've got a 10 microfarad capacitor here, which just adds as decoupling for this regulator. Then we're going into this small RC delay driver circuit here, which turns a relay on after about 2 seconds. So, and it will instantly turn off and drop out once the power is removed here, because there's not really much filtering going on here, so there's not going to be a large capacitor holding a charge and slowly discharging. So that goes through a 220 ohm resistor and a 220 microfarad capacitor respectively, and that gives us a 2-second delay turn on for this transistor here to the relay here. Now this relay actually drives the subwoofer output RCA socket, which is what that single socket on its own is for. The sub base comes in down here into one of the ends of the contacts, and the normally closed position is grounded so that there's no noise or anything on the line depending on how long the cable is going to the active sub. And when it turns on, it allows the output of the sub base preamplifier controller to come out of this connector. So that was the whole entire point of that. And you'll notice that there is over here an LED and a ground connection. Well, there's no resistor going to this point here, as you would normally put an LED with a drop-in resistor. This actually conveniently goes to the front panel's power switch, because that's a 12 volt LED. So there's already a dropper resistor inside the switch. So the power switch's LED is powered by this. So that was the only reason that's there, is to power that LED. So some people may say, Astro, shut the up and stop talking, but no, I like to explain what it is I'm actually doing. And I'm going to say this once and once again only, that I explain what I'm doing and why I have chosen to do something a certain way, so that all of you at home can understand my logic process, my thought process, the thought that went into this. So just saying, here's a schematic, yeah, I've done it, and then build a board, and then 5 minutes later end the video. What did we learn? Jack shit. So that's the reason why I tend to talk a lot. And I mean, in most of my videos, it's only the first 10 minutes of the video, and if you're really that fast, just skip it. Just saying. Anyhow, that aside, I'm going to drill my PCBs here and cut them to size and protect them and everything. And then we'll assemble them and do some tests. It won't go into the case today, although this board will, but this won't because I haven't drilled the back panel yet. But we can certainly hook it all up and test it. And yeah, so that's what I'm going to be getting on with now for the next, it shouldn't take that long, probably about an hour. And then we'll get to some soldering. Yay! Okay, and about 2 hours later, voila, it's all drilled, everything's sized up to the correct sizes, etc. And components actually fit this time, like this regulator goes in there, that fits just nicely. When I say components, there's a dead ant. Well, it was an ant. Like these connectors that didn't fit the last time I made this. Helps to put it in the right holes. Ta-da! So, yeah, all components fit. This large connector doesn't want to fit. I need to drill that out to 1.2 by the looks of things. Oh well. I was close. But yeah, so we're nearly ready for assembly, so all I've got to do is just fix that connector there, the holes for that, and that should fit just nicely. Now, one thing that I will mention when I can think of what it was is my nose keeps running. No, that has absolutely nothing to do with the price of eggs in China. Yeah, I've forgotten. Oh, I remember. There's another connector that goes here for the LED, but it's not marked on my overlay because I added it after I did the overlay. So, yeah, let me just go ahead and fix up these two holes, and then we'll assemble the thing in time-lapse for something to do. Don't need this board at the moment, that can go over there. No, don't need this board at all, really, so that can also go over there. So, just drill out those two holes and yeah, we'll get to assembling. Okay, I've fixed that hole, or those two holes, and now that connector fits in there nicely, no problem. It's mounted in my tool sideways, but that's just to clear the edges here so I can get connectors in and stuff without having to take it out. So it's all ready to assemble, so I'm going to use this to help me. It's a normal toilet roll tissue tube, or toilet tissue roll. No. Well, I'm going to do it properly. I'm just pissing about. I've got the parts laid out I need next to me here. I've also got the door open to the right of me, and I've had it open all morning actually because it's a pretty nice day. It's about 16 at the moment, so it's not that cold. So I'm perfectly happy with that temperature, so yeah, I just thought I'd air the room out a bit. It won't hurt. Before I start, I'll test this transistor, which has been used in a breadboard before, and I just want to make sure that it's still functioning as a transistor. Yes, it is. So I know that that transistor works. The others are all new and haven't been used yet, so that should not be a concern. So excuse me, I'll get started with some link wires and stuff and move on. So, yep, here we go. Okay, and there's the finished circuit board there, or almost. I haven't put the regulator IC in yet. I was going to put a heatsink on it, but unfortunately the body of this relay is in the way, so that's not going to work. There's no way I can make it work, so the IC really does need a heatsink. I could mount it that way, but that looks stupid. I mean, it's not even on the device properly. So I reckon it's probably going to get pretty warm, but as I don't have a small TO220 heatsink like the narrower version of this, I can't get them at JCar anymore. I can't make that work unless I can rob one from another kit somewhere. Just give me a couple of minutes and I'll have a look. No, I don't have anything on hand at the moment, so I'll have to investigate that later. So what I'll do is I'll leave this IC as proud of the board as possible. So actually I might make it so I don't even have to trim the excess of leads off. So I'll leave them about there and make sure I got it the right way around. Yes, I have, so I can come up with something a little later if I need to, which I probably am going to have to. So for now I'll just solder it in as is with no heatsink and just hope for the best. But because it's going to be running off the AC secondary and unfiltered, well, very lightly filtered anyway, this regulator is going to take most of the ripple. So now all I need to do is to make this one up and take the switch off the other board that's currently sitting in the amp. So I'll do this one off camera because it's not really all that interesting soldering this or desoldering a switch. So yeah, I'll get to doing that, and then we'll come back and then we'll put the this in the amplifier the correct way around. Mount the LEDs so they come flush with the front panel, and make up the cable that goes between here and here, and just find some form of voltage to pump into here to test it. Okay, so with that done, it's changed over to the new board. So all I have to do is tighten this nut properly, and the correct way to do it would be to use what I'm doing here is a spanner. A nut driver would work for these small components just as well, but we want to try and get this as tight as possible. And this is a 13mm, by the way, and there's a little bit of play in the back of the switch, but there's not much in the front. So we got 1, 2, 3 clicks, so that's 1, 2, 3, 4 positions, which is what I want. So we'll just make sure that that is tight. Now all I've got to do is pass the LEDs through the hole to the through the holes to the circuit board, and then put the front panel back on and line them up with the front, and then solder them in. And whilst I'm here, I might as well put this board for the protect LED in as well. So that just goes there, and put a nut on the back of the screw. I'm using only a 5-6mm long screw, and it's just long enough. It doesn't need to be overkill anyway. Just want to make sure that that LED is coming through the hole. Well, it lines up with the hole, I should say. It does. So I just have to come around the camera and grab hold of the nut. That's what she said. And tighten it. Of course the board moved. It would. Probably would have been better with 2 screws, but I didn't design it that way. That should do the job just nicely. So pass an LED through there as well. The anodes point towards the switch on this side, and the anode points towards the volume control on that side, respectively. So I'll just get some LEDs. Alright, so I've got 6 blue LEDs. So this is going to be fun. Well, get it to go in the holes. Just leave it sitting there for a minute. But get it to go a little bit further in. And just making sure that I'm putting these the right way around. I mean, this is fairly... I probably could have put the LEDs in the board first before putting the thing in the case. That probably would have made a little bit more sense, but yeah, I like to do things the difficult way instead of the easy way, because I'm just so awesome like that, and I'm just stroking my own ego as well as other things in the process. Yeah, we won't go there, will we? So this is kind of fiddly, but it can be done. I probably could have done it, you know, like with it standing up on its back, but yeah, right, whatever. Right, that's 2 left to go. And it looks like all my holes line up just nicely, so that's great. That is awesome. Okay, that one's a bit twisted, but anyway. Got plenty of lead coming out the back there. Now this one went the other way. That goes that way. if I can get it going the holes. Get in there. Right. The LEDs are in for the most part. So now I've got to put the front panel back on. So I've got to drag this forward a bit and get this there we go. Now I don't think I need to screw that down, so all I do now is just push the legs through from the back there, and I might put a couple of screws in the top there just to stop it from moving around. And but I'm not going to tighten them, it's just there to hold them. Because the panel's got to come back off again anyway. I might leave it on for this test anyway, I don't need to take it back off yet. So I just put 2 screws in there to hold it. And should be good enough. Okay, stops it moving around. Now just pass each LED through the front panel holes till they butt up against it. Perfectos. And now all I've got to do is just solder them from the back. So this is how easy it was going to be to do this. I'm just going to do the anode side first. I'll make sure the LEDs are still straight and poking through the hole correctly. So now, as we can see, all the LEDs are poking at the front. Isn't that awesome? I could have probably recessed them in a bit further so they only just had the face sticking out. But, yeah, no, that's fine. That's perfectos. So now I can move on to making up the connector cable. I've got to trim those leads off too. Making up the connector cable to go from the switchboard to the actual input PCB. So I've got to do those sodding connectors, and I've got to do that 6 times, that twice. Yeah, but I might have a break for an hour or so and then come back to it. I'll trim that off now whilst I'm thinking of it. But yep, she's coming on and we're nearly ready for testing. Okay, the module's all ready for testing. I've already gone ahead and tested off camera that the thing functions. First problem was the end of this cable that goes to the switch, the positive feed lead to the switchboard there, the connection point had bent over in the socket and wasn't making contact, and of course there was no voltage getting from this board to that board. Fixed that, and we do actually have lights on the front panel there, but the muting circuit for the sub bass controller here wasn't engaging after 2 seconds. I did test it on breadboard and it worked fine, but that's not loading everything down with everything else here. So what I've gone and done is I stuck another 220k resistor in parallel with the first one, which brings it down to 110k. And that's the calculation you would use to do 2 resistors in parallel. The resistance total is R1 times R2 divided by R1 plus R2, and 220 and 220 together equals 110 when you use that calculation. So I know 100k should actually solve the problem. I get around about a 3-second delay, or thereabouts. So if I turn the switch on, you may or may not hear this relay click. I don't know if you heard it, but it did actually click. But that's working now, and one of the LEDs is lit up, showing us that one channel is on. If I rotate the switch, the next one comes on, next one, and the tape switch here, when you switch it down as in tape monitor mode, the bottom LED lights up, and I can hear the relays are all clicking. So now it would probably be a good idea to verify that the audio signal, just by doing a continuity test here, is getting from each of these sockets to the output point on each channel. So what I'm going to do is I'm going to set that up and come right back. Okay, as messy as this is, I've now got that hooked up to, I believe it's the right hand channel. Yeah, it's the right hand channel. So without losing that resistor on the floor, I'll just touch the connector Right, so it's present on that input when the switch is in the first position. It should also be present here, which it is. That's the tape out, and tape in shouldn't be doing anything, which it is not. So if I now switch the next channel in, that should be dead, and this one should be active. Yes, it is, and that should be connected to there, which it is. And if I do the next one, that's not doing anything. That's connected now to there. Next, which this one should be dead. That one's now active. That one's now going to tape out as well. And that one's not doing anything. Now if I switch to the tape monitor in, that should be disconnected, which it is. That one is connected now. However, that's not outputting out the tape out as it should. Oh, it won't, because of how I've got that connected here. That's not going to work, obviously. So to verify that, I would have to bring this connector. I mean, I could have plugged a plug in that. Bring that one to there. That's the wrong one. Yeah, so it's still connected to the tape out, but it's not coming out the audio output, which is how it's supposed to work. So I know it's going through all the way through to the tape out, and if I switch my source to something, the next one down for instance, I'll just touch that one there. That one's dead. That one's now active. I don't have to test every single channel, but I'm going to, just for the sake of argument. That one's now active as it should be. Back to the first one. That one's active. So now I'll switch over to the left hand channel and make sure that we're going. I've got a short circuit now. This one might be a little bit more difficult. I mean, as I said, I could have put a little plug on that because I've got one. Did I bother to plug it in? No. So I might actually do that because I've got a grounding issue at the moment. So I'll plug in this connector. Okay, and I'm testing this side now. Now we should have nothing connected to ground. We don't. And that one's not going to work because tape switched in. Helps if I touch the right connector. Yep, that's working. Should be present there, which it is. Next, it's gone from there, it's there, and there. Next, it's there, gone from there, present there. Gone from there, it's now there, present there. Switch tape in, should be present here, which it is, and not present there until I actually touch that to the relevant connector. Brilliant. So I now know that that's going through. As for the sub bass, I believe it's that connection there. And it should be present on this. It probably might work better if I had an RCA plug to plug into it. That way I could actually, you know, measure it a little bit easier than I'm trying to at the moment. So that's that. In is at the top. Yep, and if I switch the supply off, it goes away. Switch it back on. A little bit of a delay there, but that's functioning as that should as well. So I'm happy. All I've got to do now is just change that 220k resistor to a 100k. I can't even speak now. And basically this input selector is all finished and functioning nicely. So I'll just get about changing that resistor and yeah, check it and end the video. Okay, that resistor has changed now, so it should by rights work, so I'll verify that. And the relay engaged. So that's fixed that little problem. And using the voltage regulator here was a better idea than the Xeno diode by far. So really, to complete the test, we should see how it runs on an AC transformer. It takes about 30 volts. I have got a 30 volt transformer, so I probably should hook it up to that, and hopefully nothing goes bang. It shouldn't. These resistors should be dropping it down just enough to keep this regulator happy. So, well, we can certainly find out by hooking it up to a transformer. Wish me luck. Alright, I got the 30 volt transformer hooked up, only the 30 volt side, not the 60 volt, because remember these are wired in series. So hopefully nothing goes off with a bang. If it does, it'll be spectacular, and that'll be the end of that regulator. So without further ado, let's find out. Well, it's not giving me much voltage output for some unknown reason, unless it was overloading the regulator. I don't think it was. Okay. I need to do a voltage test. Okay, so I just did a voltage test, and I have 42 coming in from the diode and about 40 roughly going into the regulator. So I believe what's happening is there's too much voltage going into the regulator, and the regulator is shutting down. So that means that these two resistors here are too small in value. They need to be increased. Probably to 1K or even higher. I'm not sure yet. What I'd have to do is experiment with some resistors. That can be done on a later date. So what I'll do is I'll change the transformer from 30 volt to just 15 and see if that at least works. So here we go. So I'll plug it in. Yeah. See, it works. Works perfectly too. Okay. However, it's not, the relay's not engaging though, for some reason. Well, at 15 volt DC input, it's only giving me 6 volt. That could be why. Because it needs to be higher than that, apparently. Although it worked on DC okay, so. Yeah, I wonder if I've got. Anyhow, I might drag out that test amp and use a transformer out of that, because that's an 18 volt one, and see if the relay's engaged then. It's worth a try. Okay, so I've got the 18 volt transformer hooked up now. I don't think this is going to make a difference to the RC delay. I think that has more to do with the fact that there's ripple now on the line and it's not regulating correctly or something, I don't know. So I'll power up the transformer. Oh, no, it engaged. So I could hear it engage anyway, so it needed to be higher than 15 volt. Probably because of these dropping resistors was limiting the current too much into that regulator, so it wasn't able to function correctly. But I now know that that's functioning on a 18 volt transformer. Not that you could see the lights, but I've just got to now play with these resistor values until I get the correct voltage going into this regulator. And running on AC, that regulator is not even getting hot, so that's only with one relay being, well, two relays being driven. That's the mute relay as well. Let's try three relays driven. That's 150 mA, which is the equivalent of 1.8 watts at 12 volts. That's not getting hot at all. I don't think it's going to need a heatsink. So that's fine. So I'll just verify the operation of the mute relay. Yep, I heard a click. If I let the capacitors and everything discharge long enough, say 30 seconds should be enough, that relay should take longer to come on, which it does. Okay, so I'm happy that that's working. So I might leave this video here. I'll dick around with these resistors at a later stage. I'm not going to do it now. The other solution would have been to put probably a Xeno diode across the regulator, say a 20 volt Xeno or something with a dropping resistor, and then did it that way, but I didn't. Someone did suggest to me to do it that way, but yeah, it is what it is. If it was a 25 volt AC signal, that'd be 35 rectified, so it wouldn't be driving it so hard. So I reckon these need to go up to at least 1.5K. 1.5K, so that's 1500 multiplied by itself, because there's two resistors the same value. That gives us that. Now we divide that by 1500, and 1500 is 3000. That's 750 ohm. Almost 800 ohms, so pretty close to 1K. So even if I went 1.8K, that was not correct. It was that divided by 1800 is 3600, isn't it? 900 ohm. So yeah, we're getting close to 1K. So the final value of these resistors will probably need to be closer to 1K in order to run correctly off a 30 volt. Yeah, but that's something I'll work out a little bit later. Right now I'm going to end this video here because it's time for a drink and it's time to edit this video and upload it so you can watch it. Anyway, I hope you're enjoying this series of videos on this Class D amplifier build. I am semi-enjoying it, making it, and yeah, this all worked out nicely, apart from the fact that I wired pin 1, which is the red lead, in the incorrect holes when I was doing the crimping, so it ended up backwards. And well, as long as it's correct at the other end and the same at the other end, it'll still work fine, so it didn't really particularly matter. So as long as if pin 1 was over here and pin 1 was over there now, pin 1 would have to be swapped on the other board as well. So as long as they were both wired the same way around, yeah, it's fine. Anyhow, I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyhow, this is the Astro 30 saying see ya. I'll see you in part 6.